testers, and welcome to another STP community webinar. My name is James. I'm the event coordinator here at STP, and we are excited to have everyone on the webinar today. Today, Brendan Connolly will be joining us from Santa Barbara, California, and he'll be talking about Jupyter Notebooks and how this tool can empower testers through automation. A few things to go over before we get started today. A reminder, we have an upcoming webinar on March 24th from Bradley Baird, and this will be a special 2-hour webinar presentation focused on team management and how you can develop management traits and skills. Register at SoftwareTestPro.com to learn how to become a successful team leader. Looking to practice your speaking and presentation skills or have an idea for a webinar topic? STP is looking for both new and veteran speakers and is currently filling the 2021 community webinar schedule. So please submit your proposal today at SoftwareTestPro.com. All right, before we get started with Brendan's presentation, here's a quick introduction for everyone on the webinar. Brendan is a passionate, community-minded software developer, tester, and automator. He is a Test Automation University instructor, recipient of the Eurostar Rising Star Award, and frequent conference speaker. He is focused on creating and executing testing strategies that enable quality outcomes while using his coding powers for developing tooling to make testing and testers' lives easier. And with that, Brendan, welcome. We're excited to have you, and the floor is all yours.
All right, thanks, James. Can everybody hear me okay?
We can hear you.
Sounds good. All right. So as we all heard, my name is Brendan Connolly, and I've been testing in kind of various capacities for over 10 years between automating desktop and web applications in languages like C#, Ruby, and most recently, and probably my favorite so far, is JavaScript. Don't judge me too harshly depending on which camp you're in. And you can find me online on Twitter or LinkedIn at the B Connolly. I also have a software testing blog, which is pretty much heavily neglected since the COVID shutdown, but there's still some good stuff there if you want to check it out. But I'm really excited to be here, and I'm glad you could join as well, especially at times like this. To still be engaged in the community is a great thing, so we can all support each other. And I'm happy to be talking to you about automation outside of just tests, especially around Jupyter Notebooks, and show you how you can use them to kind of extend your test automation. So the kind of the first thing I usually get when I start talking about Jupyter Notebooks are, well, what are Jupyter Notebooks, and what's up with the spelling? What's with the pi? Well, they're most famous for being used in data science, and that pi in the name is because its roots, the Jupyter Notebook roots, are all in Python. And actually, the first time that I heard about them was in a blog post from the Netflix technology blog, which is a really interesting read if you haven't seen it before. And it was about the role that the notebooks were playing on their data science team and how they were using them. So it wasn't exactly related to testing, but it really sparked my interest in what it could be as an automation tool. But according to their website, the Jupyter.org, a Jupyter Notebook is an open source web application that allows you to create and share documents that contain live code, equations, visual text, visualizations, and narrative text. And there's some examples there as well. But you can really see this is very focused on data science. But those applications of being able to mix code and interacting with it and text is a really powerful combination for test automation. So I hope you can see that it's a little bit more exciting than it first sounds. You can see the notebook UI here. There's a little toolbar at the top, like kind of any other app. You see it everywhere else. But what I want you to draw your attention to here is you can kind of see the mixing of the written content. In this example, you can see the equations being used, as well as the code. And then the below, and right there is the actual outcome, the resulting visualization of changing those values inside the notebook. So at its core, a notebook is composed of just a group of cells, and each cell looks a little bit like the one you're seeing on the screen there. Excuse me, still need coffee. But each cell can contain Markdown syntax, so you can do things like headings, links, images, and then what happens when you run the cell, just kind of like in GitHub, when you use Markdown inside of descriptions or any other type of thing, if you blog with Markdown, it gets rendered into these nice visualizations. So you can see the heading here, you can see that the link is interactive if I wanted to link it, and you can also display the pictures. And as you might expect, a cell can also contain code. And what we have here is an array with 3 different strings, and then we're going to loop over that array and just print out each of the values. You can see what happens is as you run each cell, the output of the resulting function is returned and displayed. So if we want to run it again, we can clear it out by, since I've commented that out, we can add these, and we can add to it. It's all live. To continue with the Eagles here, or at least one of the singers. Oops. So that we run it again, you can see its value, it's real live code. But in addition, you might be thinking, well, there's code there, but there's also IntelliSense, or I'm revealing my Microsoft and C# background, code completion. So you can use code completion inside the cells as well. When you have multiple code cells with variables and functions declared in them, anything you use in one cell is then available to you in following cells. So here we've got some variables set up as well as a function, anonymous function. So if we reload those, now we've got another cell here. We can execute it. So now you can see how you can set up data inside one cell and then use it inside of another. And this is because in many ways, Jupyter Notebooks act like a REPL, like a read, evaluate, print loop. You might be familiar with that from other languages or maybe inside your editor or IDE. But so if we change the contents though, to something that doesn't print something so friendly for the demo. So in this case, we'll use set timeout to do some advanced kind of give it a delay before executing the function. But what you'll find when we run it is we're actually going to see the output, the return value from set timeout. And we're not going to see the greeting because that greeting isn't being executed, is only being executed into memory. So we clear this out. So in these kind of cases where you don't want to display or it's not really important to render the result, you can either, in this case, since we're returning we're printing out the last value of a cell, you can add another thing on here. And I've also changed this to actually console log the result of the function. So then we run this, you'll see we're patiently waiting. And then about 2 seconds later, we see our message logged to the console. And then console log output is also directed directly to our results. But wait, that's not Python. So I mentioned Py is in Jupyter and its roots are all in Python. But you eagle-eyed folks probably noticed that I was in fact using JavaScript. And Python's a great language. I actually really like the whole Zen of Python concept. People love the language as well. It's super popular in data science. And in fact, Jupyter was created out of the original IPython project, which was built for interactive data science and scientific computing. So anytime you use Jupyter Notebooks, Python is by default included. But even in the world of data science and scientific computing, there are other popular languages. Like Python isn't, I mean, as popular as Python is, it's not the only language in data science. There's R, there's Julia, MATLAB, or other things. So to accommodate this, Jupyter was architected in a way that it supports many different languages. So you can see a little bit of the architecture here and how it goes about supporting those different languages. Users interact with notebooks via the web browser. The web UI then connects to a backend notebook server, which I'm in this case just running locally, which in turn handles interacting with the actual notebook files. Each notebook is an individual file. It's got its own format, and it's, I think, very similar to like a JSON format. But you don't really actually deal with the actual underlying file very often. You deal through the UI. But the important thing is language processing is delegated to what's referred to, and you can see it as the last green cell there, is a kernel. So the notebook server uses a message queue to delegate the language processing. So a message gets pushed onto the queue, the kernel picks it up, puts the return value and the results back on there, and then it's returned to the server. So the Python kernel, when you install Jupyter, is included and required, but there are also many community-supported language kernels as well. And here you can kind of see just some of the languages that are available. You've got Python, obviously, but there's a Bash kernel, so you can use it for running your little bits of Bash scripts or things like that. I'm sure high on everybody's list is C++ in various different ones. But there's Clojure, Groovy, Java, JavaScript, Kotlin, Ruby. The kind of list goes on and on. But what's important here is you can really see the difference. It's not just dynamic languages. It's not just scripting languages. There's typed languages. There's static languages. So there's enough there that once you can pull your code in, there's a good chance Jupyter is something that could fit inside your application's stack. So let's talk a little bit about how their notebooks relate to the languages. So generally, there's a one-to-one relationship between the notebook and the programming language being used. So inside one notebook, you define or select from the dropdown which of the available kernels that you've got installed to use. There are some exceptions. There are some multi-language kernels in notebooks. And there's this concept inside of most of the kernels called cell magics or notebook magics. And these add special functionality to notebook cells. So like inside of a Python notebook where you're using the Python language, there's a magic command, which is it's like a magic comment that'll execute a shell command or a console command so that you can intermix a console output or a shell script, a bash script or something like that with your Python output. So maybe you could generate some data with Python and then run a script to test it. I'm happy to share more information about some of those. Just feel free to reach out or in the question time or via Twitter or LinkedIn. So some of those extra ones here, just to kind of give you a little bit more details before I get you to questions. The multi-language kernel, it's a whole separate notebook setup. It's called the SOS kernel or script of scripts. And here's a couple examples of the magic commands inside Python. There's bash. You can see you could run JavaScript, print out the time. But those magic commands, another thing to call out about them is they vary by the kernel. And you can imagine why. So percent is an escape sequence in Python, right? We can see that. But sometimes that operator might not be handled so well in other languages. So the magic syntax usually comes in and is documented with the actual kernel. So you can find out which commands are available to you there inside the docs. So that's all great. Now we all know a little bit more about Jupyter Notebooks. We can start to look at how we can use them to help while testing and how we can take code and package it up inside Jupyter Notebooks and use it to help integrate automation into different areas of our testing. And that's, I think, something that's really valuable for us here, and even just as a concept, that automation so often is a replacement for testers, or it's only about actually executing tests and it kind of separate from a person. Whereas I think we can, if we can use our automation powers for good, we can start helping and assisting exploratory testing and make it easier and faster. I feel a little bit uncomfortable drawing that distinction so much, but just make testing easier for the testers. So I think automation that's kind of my mandate is I want to use code to help people, not just make sure our platform or our application is stable, but also I see value in exploration, and I think automation can help there. So the first kind of thing we're going to look at is an applications API, and this is extremely useful for testers, even outside of something like Postman. So we're going to take a look at some simple example code to get us started, and then we'll go into some more real-world situations in a bit. So what you see here is we're going to use Axios, which is a popular JavaScript HTTP client or REST client, to make a request to a Rooms endpoint. Now, the URL we're going to be using here is automationandtesting.online/room. This is like a testers or automators playground. I believe it's done through the automation and testing community. You can also, you can find out more about them there, but this is something if you wanted to practice your automation, you can use this. But what you can see here, comment this real fast. We'll make the request. So you can see in real time, we went out and we queried. We used the REST endpoint to get data back, and you can see we have data here. And what I want to call attention to is this image property of the result. It's got a URL. So maybe when you're testing this, we want to actually see that URL. That might be helpful. So let me comment this out just to make some more room. So now what we're going to do is we're going to call that the API. We're going to use the values from that API to then call to make a GET request for that image, and then we're going to return that and display it. So we're using TSLab. TSLab is a JavaScript. It's the kernel that I'm using for. It's actually a TypeScript kernel. I would probably recommend if you're using JavaScript or types, at least JavaScript, the iJavaScript kernel is probably a little bit better, but this has some additional features that make this demo a little bit easier. But what's important to call out there is when by TSLab, it's also including some helper methods here, and you can see that in TSLab display JPEG is going to actually handle taking that array buffer and rendering it to an image for us. So when we run this, you can see right in line that live image is displayed. So you can use this for capturing screenshots while a browser is running, or other things, right? Doing something like this is just an example of how it can be interactive with real meaningful data. And I know everybody loves Postman, and I like it too, but I prefer code, and that's not just because I can code. We spent all this time making API clients and API tests, and then we still use Postman, and we might have a Postman collection, but I've always kind of struggled for cases where I need to chain requests together. And if you're curious, Postman will render an image like this as well. So I thought that was a huge distinction at one point, but they will do that as well. But what's exciting here is this is just the tip of the iceberg. You can imagine with a small amount of code, you can take the same API client that you've got in your test libraries and create an interactive set of notebooks that are tailored to your API workflows and all centralized in one place. So you can make your own kind of Postman clone that has your API first-class citizen in there, already pre-wired up, the authentication's baked in, and then you can see it and reference it and share it, and not just in a single endpoint. You can show a chain of requests so you can see the behavior of how APIs work together. So you could focus on different cases on endpoint by endpoint, or model a specific sequence of those across a series of cells and step through it. So notebooks allow you to create executable documentation around your API and are more easily to act like a third-party developer. So if you need to test as somebody, an external person, like maybe a third-party group, or you've got another integration, you can model your interactions with the API directly as that integration. So I found that's been something really helpful both in previous jobs and in my current job, as we kind of have to think about and put our mindset towards what it is to be an external person that doesn't understand our API as intimately as our product team does. So sure, we can do API calls, anything, all kinds of stuff can do API calls. But when you see automation in the title, I bet you wanted to see Selenium and some web-based automation. So we're going to use WebDriver IO, and in this code, we're going to launch Chrome. We're going to navigate to Google. We're going to enter a search screen, and then we're going to take a screenshot. And just make sure I have my node registered here. All right. Cool. So we spun up our browser. Turn that again so you can see it. All right. That was some older examples. But if we run it again, you can see we've gone out, we've queried Google, and we've taken a screenshot of our API, or excuse me, of our UI automation doing its work. So you can imagine here, this is something you can make documentation for your sites. You can then run a notebook. You can run all cells at once if you need to, and then generate a bunch of screenshots, and you can have Markdown with them to explain what's going on, right alongside the code if you want. So you can imagine training your team to do more automation with this. You could show the automation code being used, like maybe this is how you interact with this component in your application. Here's the code, and you can actually execute it and see it running, either headless or with the browser actually running. In this case, even though you couldn't see it, the browser was headless, which you saw was on the code. So cool. We wrote all that code kind of inline inside the notebook. But what happens if you've got some of that code already set up, right? You've got your framework in place. You probably have existing automation code. How can you start to use that and fit it inside of Jupyter to kind of double down on the ROI? So let's talk about using that code in an existing framework and integrating Jupyter Notebooks. So I don't want to get too caught up in definitions, but to help put Jupyter in context, let's briefly talk about frameworks and some of their common components. Because when you say framework, I'm not always sure that we mean the same things. I think that definition varies from company to company or team to team. In general terms, a framework calls your code, whereas a library has other code call it. There's also an expectation that a framework has multiple consumers, different people or things being built with it. Like React wouldn't be, or Angular wouldn't be a framework if it was only Google or Facebook using it, right? The fact that it's a framework with multiple sites with different people, that kind of is what vets and makes it kind of shift from just being an internal thing to a framework that other people build with. So let's talk about Harness then. Harness is the core or the engine of your test automation framework. These are built, frameworks are built around a unit testing framework. So like the harness is what executes your code. So this is code that calls your code. It's what enables your test code to be run. So a lot of times the harness for your code is going to be the unit test framework that underlies kind of all the execution. If we take a look at the driver is the code that's used to drive your application. So Selenium WebDriver is a driver for browsers. So when we wrap Selenium code creating page objects, I like to think of it as creating a driver for the UI of the application that's being tested. So rather than just using WebDriver, I use my application driver that happens to use WebDriver under the hood. When writing similar code for APIs, I think of it as a driver for that API. That's my API driver. So under the hood, we're using a library like Axios, but the actual driver for our application is for that API is in that code there. And the content around is part, when you talk about frameworks, is the actual tests, right? It's the meat, it's what's really valuable inside of your framework. And last, we've got information and data, and this is the input and output. So we've got external inputs and outputs from tests, data sets required, report generation, artifacts, screenshots, things like that. So the stuff that your framework either consumes or generates. So what we're doing with Jupyter is we are creating automation for another audience. A lot of times the tests that we write when we're doing automation, they're not really for testers. This is kind of why there's a little bit of friction between people that do exploratory or often do exploratory testing or manual testing, however you feel comfortable describing it, and those that do automation like automation engineers. Because what I find is even though I'm writing automated tests, those don't stop me from doing those tests when I'm exploring. I end up doing them kind of inadvertently. So for a long time, I really struggled with where automation kind of fit in exploration. And that's because the frameworks are really only serving a single purpose. They're geared towards creating and running specialized tests. Those tests are valuable, but they're not always entirely comprehensive. There's cases that don't fit well into automation. There's things that maybe your code can't handle. Maybe it doesn't have a control that's easily manipulated through traditional automation. And we put so much time and effort into creating a reliable test automation framework and suite that it would be really nice and useful if we could use that to provide an automated assist for people while they're while they're testing. So our first use case that we're going to look at is something I think of as templating scenarios for testing. So we're going to automate the setup and teardown of test data, reducing the time to test. So what you're going to see here is I am going to switch to a different set of notebooks here. And then which is going to be a little bit of a disruption, but you'll see how quickly when we're using Docker to do something like this, how it works for your team. So we are online, just reconnecting my Selenium grid node. That's normal. So we need. So what you can see here is the actual UI for Jupyter. This is using a different, there's multiple front ends, so they kind of have different styling. This is Jupyter Lab. What you can see is there's a list of notebooks that are available. You can open up, so they've got a tabbed thing here, but you can see here for these scenarios, these are all inspired by Alan Richardson. You should check him out if you're not already familiar at Evil Tester. He's also got if you find him on Twitter or LinkedIn, you can find a link to his blog. He does some really amazing stuff. But what I really, really enjoyed was his test automation U JavaScript course. And what he did is he used JavaScript, but he taught it to you inside of the browser, inside of the console. And what he did is he used the console and the DOM APIs there to create automation. So what I've done here is I've taken that and I've created that with Jupyter Notebooks and Ruby. And we're going to use Capybara, or excuse me, Water for interacting with Selenium. And we've got some existing code that we're going to load into the notebooks so that we can use them. So you can see here, we've got some helpers here. And then this is our to-do MVC. That's the application that's under test. If we load it up, we can run it. And this should open up a browser visually. Pull that up here. And get the screen right here so you can all see. So you can see we've spun up the browser, we've loaded the page, it is live. So maybe maybe part of our testing is to be able to test with a large number of to-dos. Like that would take something, and you can imagine that might be time consuming for your application to set up a bunch of data. But we've got page objects or code that we can do to generate a bunch of data. So what we've done here is we've taken those, our page objects, and we've created a function that creates a random to-do, and we're going to loop over that 100 times to generate some data. So what you can see is while this is going, I can see the application, I can use it, I can interact with it, I can evolve it. It's going pretty fast, so you can do that. But you can actually interact with the browser real time while things are going. But for this case, we're just going to be using it to set up the data. So now we've got 100 to-dos relatively quickly created. I am now set up for testing. In addition to that kind of setup, we can also have a space inside of our notebooks for taking notes. So if people find information, they could be like making notes for themselves. Those can be in Markdown. And then that you can export these notebooks to PDF or to other formats, and then share those with your team if you wanted to say notes. And then since we've got our setup all kind of coded up right there, these can be in advance. The automation, if you have an automation team versus separated from your exploratory testers, they can create these and craft these scenarios as they need, and then publish them so that the exploratory testers can use them. So we've got another cell here, and they become kind of an important thing to call out is each cell, you can execute them in sequential order. You can also ad hoc execute them. So we've got another cell here that clears our to-dos. Here we go. So we've got a bit of a grab bag here as well, where you can go back, you can recreate things, you can do more work, and go through different scenarios all inside one one notebook. So we've got a different case here that's actually going to create 100. It's going to do different behavior. It's going to toggle certain ones as well. So you can have a more varied data set. And then what you can see is you can actually return values from there so that the data that's created is visible and people can see it. So they would know which ones were toggled, what the original state was. And what you may have noticed is at first all of the code cells were hidden, and that there's a plugin here because sometimes not every person is entirely comfortable with seeing code. I wouldn't advocate that as a strategy in terms of the job market. I think being at least comfortable looking at code and being around it is very useful, just as even if you don't know how to code. But what's great there's a fair amount of setup, but if you use a Docker container, I have one, I have a repo shared that kind of uses it. These notebooks are immutable. So as much as I'm running it here, as soon as I close it and reopen it, those notebooks start fresh every time. So if someone's concerned about, oh, I'm going to mess something up, it's like, no, you don't have to worry about it. Just do what you need to do, make any changes, and then if there's problems, let me know. Otherwise, just close it up, reopen it, everything will be fine. So I like to think we're planting the seed of automation and wanting to learn to code, because I think there's enough interesting stuff here that they're going to want to start manipulating things. Like, what happens if I want to do 200 to-dos? Oh, you can just change the value. And then slowly but surely, we're kind of like exposure therapy, right? People are getting more comfortable with code in little small segments. And what happens is the context of the code is very clear, not just because it's written about right there, but because it's actually helping a tester and the person looking at the code solve a problem that's immediate to them. So now that code is linked to a behavior that they already understand. And that makes it a lot easier to start to bridge that gap. So our next kind of example here, I'm going to quit out the browser. Make sure I'm in the wrong browser. We're going to take a look at using notebooks for kind of semi-automated tests. So allowing a human interactions to be mixed with automated actions. And we're going to look at GitHub to kind of imagine a complex control. So let me open up that notebook here. So in this case, we're going to use the notebook to create a brand new repository. We're going to add a file to the main branch. We're going to then create a new branch and create a pull request for a change that's been added. And then we're going to allow a user to interact with the difference view of the pull request. And then we'll wrap up with deleting the repository. But what the case here is, and you'll be able to see it in a second, but if you can imagine a difference view where you're seeing different, like the differences between two files, that might be something that's hard to automate. So maybe that's something you kind of consistently hand off to your exploratory testers, like, oh, we made a change to the diff area. We need to explore there and make sure it looks right with these different cases. Well, now we can kind of, rather than having to go through and do some of these steps manually each time, we can set up all that for you and just kind of seed control of automation to the tester as they go, when they're ready to do their exploration. So we're going to use the GitHub API. We're using the AutoKit gem here to wrap the API, and then we're going to create a repo. So we'll run that. So what's really nice is now we can actually return the URL to the repository that we just created. And if we open this beside, oops, got a little click happy there. Apologies. I don't know about anybody, but my home desk game is not the same as my previous work desk game, so it's a little slower on the transitions. But now you can see we've got this. We can see it working. The data that is being created, people can see what it is, but it's also really easy, right? Like, oh, I don't have to like run a script, pull it out of there, pull out the URL. No, I can just, here's the link, click it. And for me, when I'm exploratory testing, the easier I can make things for myself to do a good job testing, the better. The easier it is for me to get into the flow, all kinds of things. So now we're going to add a file to the main branch. So kind of continuing down this thread, we can display data that's maybe your tester frequently needs. Maybe it's hard to get that data out, but now here's the SHA of the file that we just created. You can see it. Now we've created a folder with the file in it. So as we're executing, we can see it live. We'll create a branch. Same thing, we can display API responses below so people can really see. There's no hiding of information that's relevant. There's no context switching between API and browser. I've got both up. Maybe if you have two browsers, you could have both browsers going at the same time with different things. We're going to add a file to this new branch. Here's the link to the file. Same time that you can see how easy, and this becomes a record of your testing as well. So people go back and say, well, what was the link that was created? What was the SHA? I just have to look back up the string of cells and I can see it there. And I will create the pull request. Just go through here right now. There's a link there for right now. I just don't want to thrash between browsers. You can see that we created the pull request. So this is where we're going to put on our kind of imagination hat and imagine what it would be to try to automate something that looks like this. Like we got one file in the beginning. This is what it was. And here's the change when product changed their mind. Now, this is a really simple file set, but you can imagine when there's multiple changes here, multiple files, that could be difficult to kind of work your head around. But here we've got it all staged up, files there. All I'm doing is I have enough information to make sure my questions are answered, but I am in testing right away. No context switch. Got the browser up, I'm good to go. I'm in testing here. As soon as I wrap up my testing, I could be taking notes here if I wanted to see like this is what happens. I can also have additional automated steps. I could add code here if I wanted to, and then execute it. But then we can just go through and kind of clean up and delete the repository. See, hopefully it gives us, and now it's actually deleted. So what you can see is just how powerful we can take. This is the same type of code that you'd already have inside of your repositories. And if you don't have maybe like the random part or some other things, it's just a little bit of extra effort to take what you did your existing framework code and make it a little bit more extensible and usable for exploratory testing. And you've got now multiple consumers, which now really changes your ROI calculations because now you're cutting time off exploratory or manual testing and more frequently using it. And now you might even be encouraging some of those people that wouldn't be in automation to get into it. And last, we're going to take a look at kind of creating an exploratory testing toolbox. Close this out. So in this case, I've got two examples, same type of thing. We're going to be using the Alan Richardson kind of model here. But what we've done is we've kind of created a different grab bag of activities that we can run. So we're going to spin up the browser, pull back and over here. So now, maybe part of your testing, it's not specific to one area, but you need to spin up some different types of data or make some changes. And it's like, you have to do certain amounts of, it's kind of like setup, but more like you can do this ad hoc as you're testing. Like, oh, okay, I need to create a to-do. Okay, that's created. I want to do some other testing myself here, mine, add it. I can go through, I can update a random to-do. It's like, okay, I need something to be updated. There's some problems here with the random values, maybe inside or outside of the range. So let's create a few. Oh, well, this happens with live code. Oh, this is what happens when you thrash between languages. So what you can see, but you can, the important part is you can continue to execute cells. They can be in different orders. You can do different behaviors. And what you've got here is, these are simple, like it's just enter a value, press enter, and now you've got it to do. It's one click to toggle. But I don't know, in my experience, there's a lot of times where I might need to create a particular work item, maybe something linked to it, and a fair amount of little bits of data, but I need to do it repeatedly. Like, okay, I need to do it with this data, or I need to do it again to test some other behavior. A good example of this in my previous experience is I worked with an ERP system, so for enterprise kind of accounting systems. And the application I was working on integrated with those kind of old school legacy, not web-based accounting systems. So we could never automate them all. And then there was a fair amount of having to go through to the other system and verify. But almost all of my work was either in setup or in the doing bits of automation inside the middle of my workflow, so that I could create the environment that I needed, set up my integration, create the code that needed to be exported, maybe the change that needed to be pushed to accounting. And then what I would do is I would uh, seed control like this to be able to do the accounting part, to the actual push to accounting, and then I could pick up and clean up that data and verify it inside of a notebook. And it was incredibly useful and it saved time. And these were all cases where we wouldn't be able to have any automated coverage for that functionality. So it was always going to be debt in terms of testing debt, and it was always going to be exploratory or manual steps. So now what we've done is we automated enough of that to make it time, to take some of the burden of time and repeated manual actions away from those tasks. Because what happens is you lose track because you're so focused on doing the other things that aren't really relevant to the change that you're making. So the more you can keep a tester focused on just the change that's being made, the better, and the more useful it is. So beyond that, you've got this toolbox that's for creating random things. Oops, that's the wrong one. What if we could create bots that are interacting with our application while we're using it, maybe in the background or maybe kind of live? This is what Alan does inside of his course. He creates a bot that runs and it generates data and is acting through the application while he can be using it. So this is that same process, but with Ruby and inside of Jupyter. So what we'll do here is we'll spin up the browser again. So what we're going to do is we're going to define a function here that gets a random action from our page objects. So take an existing page objects, and I have wrapped them into a random bot. Now this helps with Ruby because it's dynamic. I can get the instance methods and then iterate through those. But it's relatively easy to do with JavaScript, and you could find ways to work it with typed languages as well. So that shouldn't be a problem. And if this code looks like something you wouldn't want to be showing to people, that's fine too. It's present here to show that you can create a function that's used only inside of the notebooks, and then what that code would look like to generate a bot to be doing it, and then also, or at least help generate a bot. And then also, this is, you could, in practice, this is something I would hide inside of a file or another class, so that the notebook code would be more simple. So now we'll start. So what we're doing is the bot is running, it is doing random actions, it is logging those actions as it goes. So what you could imagine is maybe you have a chat feature and you want to have somebody else working on chat while you test the change that was to your chat panel. Okay, fine. Well, now we've got a bot that's running in the background. I can open up a new tab, open up the page, and I could be seeing that to-do application or the chat part of it going while I'm testing it, all from inside of a notebook, all easily done. There's no like, hey friend, can you help me test this real quick and do some chatting or organizing a group thing? You can spin these up, they're right there. It's randomized, so it acts a little bit like a user. I think we've all seen some of our users feel like they're doing random things at times, although I'm sure they have their own motivations. But what you can kind of get to see is you can make use of your automation in ways and to really extend the value through small changes. That was one function to generate a random action. And then you can use all of your existing page objects. And then I could have another notebook where I'm interacting with the API with this live. All kinds, the kind of opportunities are really, really broad. And I think it's another harness that we can introduce inside of our testing. Kill the bot here. Close the browser. So one thing before I wrap up and we get to questions, one thing I want to show is this whole presentation has been actually inside of a Jupyter notebook. There's a slides integration that's built with it called Rise. But you can see here, the notebook is there, including the notes, live and interacting. I can go back into this thing. I don't have a link to it in here, but what I can do is I can share out, there's a repository with this presentation and all the code that went into it. And in there is a link to Binder, which will actually spin up the container for you on a remote server, and you'll be able to launch the slides and be interactive for you on your own. So they should work. Everything should be fine. The only thing that won't work will be anything browser related. A little bit on the architecture there. It's using Selenium grid, and I'm running a Selenium node locally. So what it's doing is routing from the container to my Selenium grid and then launching a browser locally. So the remote browser, the remote Docker container doesn't have that. The Selenium grid would be then it'd be a random URL and be harder to do. So that's not available. But you could run it locally the way I did here. There's a Docker compose file. But yeah, so with that, take care of yourselves, especially now. Create and share. The more we can share together as a community, that how we're doing things, how we're solving problems, open source libraries, the more we can help people test well, the more we can be a better community and do that. So please reach out on Twitter or LinkedIn. I'm on the Connolly, or again, my blog is brendanconnolly.net. So thanks. I think we have time for questions.
We do. Thank you so much, Brendan. That was a great presentation. We do have a few questions. Are you ready?
Ready.
All right. So this one, it's two questions. I think you answered one of them, but does it support Java, and does it use Selenium WebDriver in the backend?
So yes, Jupyter supports Java as well as Kotlin if you're interested. I am using Selenium under the hood. So I was using WebDriver IO for JavaScript, which is Selenium under the hood. I was using Water, which is also Selenium bindings for Ruby. So an important distinction, though, there is no Jupyter itself is not a test automation tool. It's you could run any code in there. You could load up your application code. You can ad hoc. So there's a bit of a separation, but any code that you can require or import into the notebook, you can use.
Okay, great. Any other questions we have out there? Just waiting. We have time for a few more questions. Another one. Here we go. Could it be used for testing performance, perhaps with the percent time?
Yep, you can, especially around like API calls, you could wrap those in that and have it tracking that.
Great. Any other questions for Brendan? It doesn't look like we have any more. If any more do come in, we'll be sure to pass them on to you. But thanks, Brendan. We enjoyed having you today. It was a great presentation, very technical. We loved it. And hopefully we will see you in person next time. Hopefully
That would be
sometime in
great.
2021. Yes.
I miss my STP con.
I know it's been a long time. I know it's been tough. So hopefully we can get some good news here in the next couple of weeks, and STPCon will happen sometime in the end of 2021. But yeah, stay tuned. So thanks, Brendan. We appreciate it.
All right, thank you. Have a good day, everybody.
So before we go today, just a couple of reminders. Our next scheduled webinar will take place on March 24th with Bradley Baird. And he'll be giving a special 2-hour presentation on how to become a great team leader and develop your management skills. So visit SoftwareTestPro.com to sign up for this webinar, view all the upcoming webinars from STP in 2021. If you'd like to be considered for a webinar presentation or have an idea for a great testing topic, please visit SoftwareTestPro.com to submit your proposal today. And with that, thank you so much, Brendan. We enjoyed having you as always. Again, we hope to see you soon in person, but thank you for everyone who joined today, and everyone have a great day and stay safe.